Hey, hi, Aaron. Yesterday we have seen RNN. We looked at the yesterday we looked at videos in RNN and understood what is happening. Hmm. Key things are the base RNN model. I think we understood it well, but we need to look at those variants, how they work and stuff. We should actually look at a sample output so that we understand it better. So, like the sequence to sequence models or something where um, the input is given. So input usually is taken from a series of um, input is taken from a series of values that could be text or not series, it's time series or a sequence of values, like what I am saying now, that those are list of words, right? Similarly, house prices from last 10 years, um, average price of every month, 10 into 12, 120 prices, um, like that. If there is a sequence of like our um, human birth rate, our weather temperature from last 20 years, like that, if you take the information, so that information will be most probably whatever examples I said are time series. So they'll have sequence of values, and they show how they are varying and all that stuff, right? So what we need to do is these are actually more aptitude questions that you see online, saying given sequence of numbers, what is your next possible number? Similarly, like given sequence of prices of a stock, what is the next possible stock? Given sequence of weather temperature, what is the next possible weather temperature? Or given sequence of words, what is the next possible word? Like that. So what does it depend on is it depends on um, it doesn't depend on all the values. It doesn't depend on each value individually. It actually depends on all the values and also the pattern in which the values are varying. Like becomes B becomes C becomes D is followed by E is followed by F, and stuff, right? So how does that what is the what do we solve that when we solve such kind of a problems? What do? We see a correlation between AB, BC, CD, EF, and we make sure that the correlation that you assume between AB is applicable to. I think we should actually try to solve some problem online. It should be, let's see, number sequence problems for next number prediction. Find the next number. See, if we take something like this, um, find the next number in sequence 3, 7, 15, 31, 63. Okay. So what we will do to solve this problem, we look at what are the numbers that are there. First we look at 3. Okay, 3. So from 3 we can infer a little bit, is it's an odd number, and third number in the number series and stuff. Okay. Then we have 7. Now if 7 is also an odd number, which is okay, and how is 7 related to 3? It's not a multiple of 3. Okay. Is it an addition of 3? Yes. 7 is comes after 3 is you added 4 to 7. Then, if sorry, 4 to 3, you get 7. Um, and any other way we can represent division? No. Multiplication? No. So all those are not possible. So one observation that we had is um, it is 4 varying. Okay, very good. Now we move on. So we will remember this saying 3 and 7 are there, and the variation, the pattern could be addition of 7. Now you go to the next step, 7, 3, 7. Now 15 comes in. So what we will do, we'll look at what is the difference between 7 and 15. 7 and 15, if you look at it, it is, there is no multiplication, no division, nothing. What is the difference? If you see, it is it 4? No, it is not 4. Then what is the difference? The difference is 9. Sorry, it's not a 9, it's 8. So 7 and 4, 15 is 8. Very good. So 3 and 7 is 4, 7 and 15 is 8. Now let's get to 15 and 31. 15 and 31, difference is 16. But again, same rule is not there. And 31 and 63, the difference is 31. 32, sorry. So as you can actually see, as you look at everything that you understand, it is 4, and then it became 8, and then it became 16, and then it became 32. The next number will be 63 plus 64, most probably. It will be 127. So if you see the answer, where is the answer? Yeah, so I think these are all very good, but I don't know. There is an answer for this. Find. Log. Is this the... Oh no, the numbers changed. Okay, fine, doesn't matter. For solution steps, click on the link below ads. Of 3, 6, 18, 72. Okay. 3, 6, 18, 72 is, now if you see, 3 and 6 is multiple 2, 6 and 18 is multiple 3, 18 and 72 is multiple 4, and 2, 3, 4, then 72, 5 is 3, 50, 10, 360. 360 is the multiple. So 360 should be the next number. Let's see. This guy is... Okay. Take your time, man. Take your time. Oh, previously also there's solution below. I didn't see it properly. Okay. So yeah, 360 is the answer, as I said. So what it did, 3 it took, and it has looked at is this 2. Then it is like 3 is multiplied by 2, then 6 came. So it has taken that factor. See, it can also look at like saying 3 plus 3 is 6. That could also be considered. Okay, that's also one way. Yeah, I see as a solution 1. Yeah, it's here. See? That there will be multiple patterns within the series of numbers. So we need to find out which series is the one which we need to use. That's all. So ECSCN 3 into 2 is 6. And then 6 into 3 is 18. 18 into 4 is 72. 17 into 72 into some number should be there on the next one, if you say think so. Then they look at the second level pattern, that is 2 and 3 multiples. What is the difference? 1. 3 and 4, 1. We need to look at these patterns until we have a similarity across all those numbers. Like here, you see 1, 1, 1, 1, 1 across the place. So that kind of a pattern, once we find out, we can actually say, okay, this is what my next number is. Other solution, this series using a differences result correctness. Okay, so 3 plus 3 is 6, 6 plus 12 is 18, 18 plus 54 is 72. Then we need to find out what is the number here. 3 and 12 difference is 9. 12 and 54 difference is 42. 9 and 42 difference is 33. So now if we assume 42 plus 33 is 75, 75 plus 54 is 129, 201. So next number for given series may be 201. So I think possibility is technically that's also possible, but the solution, actual solution is 360 because of this pattern. So maybe they should give saying there should be this pattern or something like that. We have entered 4 comma separated numbers. So again, forget about this, but the intention is the primary intention of this whole stuff is there is a pattern in which these numbers change in sequence, and basing on if you give only 3 and 6, the pattern could be multiplied by 2 plus 3 multiple things, right? So the pattern can vary, but when you have sequence of data, you can pick multiple patterns as I said, and those patterns we can should validate it when you go ahead and then see, okay, out of these 4 patterns that I thought of, 2 are applicable and 1 is not applicable, like that. If there are multiple patterns, you uh, make changes accordingly. Okay, so that is with the sequence of numbers pattern and all the stuff, and then how it works and stuff. Well, this is there. um, the expectation from RNN is same thing. Whatever we did manually now, RNN looks at 3, RNN looks at 6, 18, 72. So it need not necessarily remember 3 as is when it comes to 18. And it needs to remember that 3 into 2 is 6, either this, or 3 plus 3 is 6, this. And when it comes to 6, 3, it should validate whether 6 into 2, is it 18? No. 6 plus 3, is it 18? No. Then it should look at what is 6, 18. 6 into 3 is 18. Now it can look at what is the difference between these numbers. How does this pattern change, right? So that's also one way. So it can't be basing on one single factor, right? It should be actually multiple factors into considered into to finding the solution. So good. On name of this, we could actually do some number series and stuff. But number series could be complicated as well. So, for example, the previous one we have seen, we can solve it in another ways. That is, it can actually be a 3, 7 something, right? It could also be in a pattern saying 2n minus 1, something like that, where n is these numbers. That might also work because you see the numbers are 3, 7, 15, 63. So they are like 4, 8 plus 1 of all those numbers are 4, 8, 16, and 64. So all of them are 2 powers and reduced by 1. So that's also a pattern. So for us, by looking at those numbers, because we know the 2 power is this, we think of it and we come up with that factor. But whereas in a computer, it doesn't know, right? Doesn't know that these are all 2 power and something like that. So the only way it could get to the detail is to understand try out multiple combinations. Again, which combination will work or which combination is what, we don't know. Which combination will fit into all the numbers also, we don't know. And there could be multiple, as we have seen in the other solution, there could be multiple patterns that could, when you go multi-level, there is multiple factors that could fit in, or we can squeeze in those multiple factors into the series and also derive the number. whether the factor is whether the pattern is correct or not will be visible only by predicting a number and then finding out the actual number. For example, when you have series and then you have 63 at the end, we'll remove 63 as if we don't know. Basing on the first three numbers, we predict 63 and see if you are able to predict 63, then your pattern is good. Then you can apply and predict the next number. So that's how you can train the model and start predicting the future unknown values. Okay. So this is all good, but now what we need to understand is for a given sequence of numbers or words or something or even image, how does it train by taking input one at a time? How can it predict the output? For example, especially the most interesting that we want to observe is when there is one word and you try to predict a sequence to sequence. If you look at it, you know the diagram, right? So there are multiple neurons in sequence. If I give what is my name and give what or what is your name, and then I give you what, it's saying basing on what it will actually predict something. Could be my name is Alex, something like that. But how does it know when I give what? It knows that I'm going to ask what is, because what is your name will be my name is. What is the meaning of something, then my will not come. So how does it know in sequence to sequence? How does it know which word should be predicted basing on the RNN flow? So that's very important. So we should look at an example to see how it happens. So let's try to see if we can find any example online. That is the lazy way of learning things. The actual way of learning things is to go write some code, print the output in between, and then see how it works, right? So then it is much better. RNN network with an example. Sample data flow. This could be power of recurrent neural network. Let's look at it. And then you'll go to diminishing gradients, exploding gradients. Implementation. We'll implement full neural from scratch using Python. We will try to build a text generation model using an online. We train a model to train of a character given the preceding characters. So we sample an X character from predicted probabilities and repeat the full sentence. This implementation is from Andrej. We're building a character level RNN. Here we will discuss the implementation details step by step. Initialize weights matrices U, V, W from random distribution and bias B, C with zeros. Forward propagation to compute predictions. Compute the loss. Back propagation to compute gradients. Repeat 2 to 5. That is ANN process itself, same, right? Let's assume we pick vocabulary says vocab underscore says 8000 and layer says 100. So input xt is 8000. Amma. What is 8000 again? Out in X, I'm assuming X is input. I think we would have explained them on the top, but we didn't see. Hidden size is 100 neurons. Very output will be 8000. The implementation is to predict the next character. There should be only one character, right? It should be like sequence to vector implementation kind of stuff, but let's look at it. VW is it has an more than next character of the unique characters in our vocabulary. So the class and laws. Some of long loss. The class level C and the models were implementation as well. Nine principle are a simple and powerful model in practice. It is hard to train people among the main reasons why this model is unwidely other vanishing. While training using BPTT, the gradients have to travel from the last cell to the first cell. The product of these gradients can go to zero or increase exponentially. In gradients problem refers to large increase in the norm of gradients during training. Gradients refers to the opposite behavior when fast to non-zero, making it is impossible for the model to learn. Okay, language episodes will further under text. Okay, predict. Okay, so this is sequence to vector, so this is okay. But, you need to look at how sequence to sequence of sequence. Let us see how RNN is learning after few epochs of training. Year Hope Westir on trained my first neural recurrent network. Okay. And so after a year, predict gives what is predict now doing? Start comma n. Image the choice of activation function for the hidden. The output looks more like real text with word boundaries and so. Whereas also our baby RNN has started staring, has staring learning and is able to predict the next few hours implementation. So in case you want to realize what's hmm. Not with variety of structures then. Well, you should look at it in a big screen. So the input is going to be 1 0 1 0. Output sequence is expected to be 0 1 0 1. And so this is the network, and it has hidden states or hidden size is 3. So the initial input 0, weights will be there for these are weights for the hidden layer. Mhm. Input weights, it is X. Hidden bias terms, okay. Bias 0 across all. Median state previous is 0. His meaning of hidden state is actually the output of the previous state is hidden state H. Okay. And this is for output hidden state output plus these weights based, then it will give output. Okay. Q is for actual weights of the input. For T in range, length of inputs for each input access. Zero zero. One. So they make character 1, bias is 0. And P of tan H of input weights U and access T. hidden weights into hidden. So ux plus wh plus b bias term. Very nice. That he is putting it on tan h. Tan h is his activation function at this level. And that will give these values 0.05, 0.06, minus 0.02, because it is three size, there will be three outputs. Okay. Now, next step, output. Output basing on this 3, this multiplied by this plus output bias. These 3 will give output as this one. So the probability target is 0. So loss here is 0.69665. So because 0.50, 0.01. This 3 will be input here. Oh, he's taking two variables and he's representing which one is the value. So first, if 0 is the value, it will make this one as 1. And if 1 is the value, this will make this one as 1. So that's how it indicates which one is 0 and 1. Okay. So that first value, because 0 is the value, it will make 1 0. If 1 is the value, 0 1. Okay. Okay. The hidden layer output is not good, and that being multiplied by this will give output this one. Loss is more 1.38501. Interesting. Now 0 1 because 1, and then ux plus wh plus b. This will give you output. That is 0.06 tan h, and this into this plus this minus 0.01, 0.02, 0.50, 0.50. Again this So this is clear. First pass through all layers. What is the output and stuff? Note that its output probabilities of roughly. And then this animation looks pretty cool, but you probably won't. Mhm. Mhm. So this guy has done back propagation and he come up with some weights. So U and W are different. See, U and W here are where? U and W here are 0.05056 to 115 to 1652. Whereas here it is different. See, numbers are different. So with these updated weights, if and bias also has they've added some bias as well, and the output also they've bias is still 0 here. Why is he saying loss 0? Ice is defaulted to 0. Okay. Instead of making hidden layer 000 initially, they're starting with 0.95 and 0.98. Use 1, then it becomes 0, 1. It is 1, 0. That means 0. Super. You should have listed the prediction also here to be more clear. Nice. Zero point triple zero one nine zero. The time our network output properties are 100%. It also in 1 minus 1 1 1 minus 1 1 minus 1. That's correct. I can pretend. But it's interesting to see. In fact, the more we start thinking about it, the more it's interesting that hidden underscore state learns anything at all. Hidden state is meant to encode useful information about things we non past information on here. If you wait, if you want hidden state to be useful, we'll have to give it problem where it's actually needed. We'll modify our original sequence slightly and have Predict the next character. Okay. No, network cannot. Simply predicting the opposite of the input. It will have to take a special care to determine whether we are first or second one. When predicting the output below is an R trained and respondent input characters 1101 to 1011. Okay. We are on the instead of the animation progress. Okay. So same thing. Code is all same. Weights may be different. Bias terms are also added. Okay. Also adding 1. For one, it gave 1. For the next one, it will give 0. 1 0 is 0. This time hidden state is actually encoding useful information we can observe directly. Whenever the network says 1 in the sequence, the hidden state is set to 0. Contracts when the network sees the second one. 0.97, Having hidden state like this allows our network to output the proper probabilities of each step despite doing the same. In terms of hidden state and interesting, so convincing our network to either remember or forget different sequences. Domains. Excellent, man. I love this. This should be there somewhere. You should remember this. Linear. No. Edit. UNDP, Unia, AML. Very good. Excellent work. This guy has done excellent work. This is exactly what I want to do, and he did it without putting any effort, without of writing a program to see all that. But so U, W, V. These three things are the weights. Input. This is for a hidden layer, and this is for output layer. When you go, see, remember this 562, 1652, 69. 562, 1652, 69. See, same thing is being continued. Even bias term 000 also same thing is continued. So literally we are having one network that is being repeated multiple times for each input. Also taking in the into consideration the output of the previous input. This is exactly what we do. What we do with the time series state. I mean, number prediction example that we have seen. But interesting thing is the weights of it is not multi-layer neural network. The weights are not changed at each iteration. It is the same weights multiplying the output of the previous one and the input of the current one. It is able to predict. And if you can't edit this code, otherwise, if you put more, I mean, visualization also will not work. If you increase it, you have to see how it will work for multiple layers like this. This is amazing work, amazing. Join us at a live programming demo with this is just Code Max 2016. Chicago, here we go. Mm, nice. Good job, man. Good job. Yes. Okay. Anybody else who did better? All pictures, no demo. Nice. Last time GRU. Okay, we'll pause for today here. We didn't even go to LSTM. RNN only, we looked at it one more time. It's very interesting, no? How same made. If you look at it, tan h of hidden into no input into weights plus hidden into weights plus bias, and the whole all of it being put together into an activation function. That's in turn given to next equation. where it is again multiplied with h0. Let's try to we did. If you look at it, so the incoming for RNN, let's pull a diagram for you to understand it better. Yeah. Mm. Hmm. Bidirectional RNN, interesting. That's something we can see later on, but single direction RNN, where is it? Where is it? Where is it? Where is diagram? Man, no diagram here. Yeah, even if you take here, so if you take here, we can go to his page is there. That's excellent. Why do you need all this nonsense crap? We don't need. Yeah, go to this diagram. So x weights are u, h from the previous hidden state weights are w, and output weights are v. Correct. So forget about output weights for now. Let's talk of the what will happen. Activation function tan h of x into u plus h into w plus b, but let's make b 0. Then it will be xu plus hw, what is being considered. And once you, that is at this layer level, first layer. Okay. So let's call x as x0, h as h0, and our x will call as 1 because h0 is coming from the previous step, x1, first input, tan h, right? U and W will be same. Now this will become H1, correct? Yes, this will become H1. And H1 given to V, like V H1 plus B, V and B bias being 0. This, and again maybe they'll apply some tan H or something like that, softmax, something on this, and this will give us output. But this is specific to one iteration or one time step, right? Output is equal to output weight into hidden state plus output bias. Okay, he's not even doing any uh, function softmax or anything on top of it. He's just directly doing this. Okay, which is okay. Doesn't matter for us. Probabilities and p dot exp of output by and p dot some whatever. Okay. Now coming to this layer, it will become tan h of x2 into u plus h1 into w. If I replace h1 here, this is h2, x2 into u plus h1 is tan h into xu plus h0w, x1 into w again. Because tan h is there, we can't send this inside, but if you look at it, it will be a loop. So for third, the fourth, it will become x3 into u plus tan h of x1 x2u plus tan h into x1u plus H0 W into W into W and again into W. So into W for this and then into W for this and into W for this 3. It's W cube. U is only x3 into U plus tan h of x to U plus tan h of no W cube will not come because there is a tan h outside this. This bracket is tan h, so W can't come outside. It's tan h of W. So W into if W hit tan h x comma y is, it's not like that. Yeah, we can't say tan h of x comma y is tan h x into tan h y. I don't know. Let's not go there. So this is the equation. If I calculate once instead of iterating also, if I calculate this once, I'll get the direct output of the third iteration, the third time step. Similarly, if I go iteratively, it will become, so if you see here, we can clearly see x1 is there in this equation for third iteration. I would like to show you guys this, but I don't know how to show it. It is on my book. But so I'm not sure if you guys can see it, but this equation, what's the big deal now? Let me send the photo. So if I is it in screen sharing? Oh, it's not. So if I go for screen sharing, let's pull this. See, if we look at it, what we are doing, third step. See, the first step is here. H1 is equal to tan h of x1 u plus u is weights for input. HO, that is initial input that is given HO. Usually you can start with 0 0, but final prediction that we see that it is not ideally to be 0 0 into W plus B hidden with H bias will be there, but let's say we assume it is 0, then it is XU plus X1U plus H0W. H2 will become tan H of X2U plus H1 into W, where H1 is tan H of X1U plus H0W. So if you keep it, it will become like this: tan H of X2U plus tan H of X1U plus H0. And if you keep going like this, if you see X3, tan H of X3U like this plus H2W, where H2 is this one and in which H1 is this. So if I keep here, this one in place of H2, that is this into W. So what will it have is tan H anytime xn will have tan H of xn minus 1 into U plus tan H of x minus 2 into U plus like that it will go till H0. So what is going to happen is you have x3, x2, x1 and H0. How many abbreviated steps you go, those are common, and U and W are also same, but the only thing is they're multiplied inside tan H function, so we can't pull them out. But U and W is also same. So for given inputs, we are actually putting all of them into a single equation. So for each step, the output that is there, we can also predict it in one go using these equations. That's also possible. Only thing is, we instead of doing all those math in one step, we are dividing it and conquering, saying we calculate one tan h first and then tan h inside with, so that means we calculate this tan h first, take the output H1, you put it here into another tanh, and I mean tanh is activation function, but yeah, here let's assume another tanh, and this you take it H2, you put it into another tanh of, like that. If you keep going to multiple levels, uh, and you derive it, but always the equation of H is dependent on inputs x1, x2, x3, x4, x5, those u weights of x, w weights of hidden layer, and the HO, the initial input HO hidden layer output that you give, which is imaginary. There is no step before it. It's zero step, but we give some value there, which could be zeros or whatever, and that only those are influencing what is going to be the output of the particular step, which shows saying there is influence of all the inputs on every step's output, and also the HO, initial input that you give. That's how it works. Nice, man. I love this. Love this. Aranan. Okay, I did stop sharing. Yes, I did stop sharing. Okay, I'll end the video now. We've crossed 1 hour today. It's a lot of time. We should join work. It's 9:20, man. My bad. Bye.